Have you ever wondered how computers actually, well, think? It's not magic, I promise. It's actually a secret language made of super simple but really powerful symbols. And these symbols turn basic commands into all the amazing things we do online every day. So let's dive in and decode it together. I mean, think about it for a second. When you type your password into an app, how does it know it's the right one? Or when you're playing a video game, what's the trigger that tells the system, yup, they've won? It all feels so complicated and instant, but the answer, it's surprisingly simple. And there you have it. It all boils down to these little things called operators. These are the fundamental symbols that computers use to get things done. They're the basic building blocks for doing math, for comparing things, and ultimately for making every single decision. They're pretty much the secret workhorses of the entire digital world. Okay, so to really get this, we're gonna break it down into 3 levels. First up, level 1, the calculator. This is where it all begins. It's the most basic skill a computer has, just doing simple, straightforward math. The tools for this level are called arithmetic operators. And yeah, the name says it all. They handle arithmetic. The best way to think about them is just like the buttons on your calculator. Each one has one very specific job to do. And here they are. You'll probably recognize most of these from math class. You've got the plus for addition, minus for subtraction. Now, in programming, that little asterisk stands for multiplication, and the / means division. It's really that straightforward. These 4 symbols are the bedrock for every single calculation a computer ever makes, no matter how wild it gets. And this just shows you exactly how it works. Let's say we tell the computer, hey, there's this thing called x, and it's 10, and there's another thing called y, and it's 5. The moment we write x plus y, the computer knows exactly what to do. It grabs those numbers, does the addition, and boom, the answer is 15. Simple, clean, and super powerful. All right, so computers can do math. Cool. But what's next? This is where it starts to get a lot smarter. Let's head to level 2, the judge. After calculating numbers, the next big skill is comparing them. This is where the computer learns to evaluate things. And to do that, we use what are called relational operators. Their entire job is to look at 2 different things and answer a dead simple question. Is the statement true or is it false? In the world of a computer, there's no kinda or maybe, it's all black and white, yes or no. And that simple true or false is the absolute core of every decision a program makes. So, here are the main tools for being a judge. You've got your less than and greater than signs. Easy enough. But pay close attention to the next 2. To check if 2 things are exactly equal, we have to use a double equal sign. And this is so important because a single equal sign is for assigning a value, not comparing it. It's a classic rookie mistake. And finally, if you want to know if 2 things are not equal, you use an exclamation point right before the equal sign. This is a fantastic way to picture what's happening. In our heads, we ask a question like, is 5 greater than 4? Well, the computer asks the exact same thing. It just uses these operators to do it. It looks at 5 greater than 4 and thinks about it for a nanosecond and correctly comes back with the answer, true. It's that simple, yes or no logic that runs literally everything. Okay, so we've learned that computers can calculate and they can compare. Now for the final level, and this is where it all comes together. Welcome to level 3, the strategist. This is where we take those basic true and false answers and start combining them to build some really sophisticated, smart-sounding logic. The tools we use here are called the logical operators. Their whole purpose is to chain together multiple of those true/false questions so we can get to one single final decision. This is how you build complex rules for pretty much any program you can imagine. Let's kick things off with the first and honestly the strictest of the bunch, the AND operator. You'll usually see it written as 2 ampersands. You can think of the AND operator as the really tough bouncer at a club. And here is the one unbreakable rule of AND. For the final result to be true, every single part of the question has to be true. If condition 1 is true, and condition 2 is true, and condition 3 is true, only then is the final answer true. If even one tiny part is false, the whole thing comes crashing down and becomes false. No exceptions. This real-life example makes it crystal clear. Let's say our personal rule for going out is it Saturday? And is it raining? So let's follow the logic here. First question, is it Saturday? Yep, it is, so that's true. Second question, is it raining? Let's say, nope, it's not, so that's false. So because we use that super strict and, we needed both things to be true. And since one of them is false, the final decision is false. Sorry, looks like we're not going out. See? One no spoils the whole plan. But what if you're not so strict? What if you need a little more flexibility? Well, that's where our next operator comes into play. Meet the OR operator, which looks like two vertical bars. OR is basically the super chill, easygoing friend of the strict AND operator. With OR, the rule is so much more relaxed. As long as just one of the conditions you're checking is true, then the whole thing becomes true. It doesn't matter if all the others are false. Just one yes is enough to get a final yes. And this is the perfect way to think about it. If someone tells you, for dessert, you can have ice cream or chocolate. You're happy if you get ice cream. You're happy if you get chocolate. You'd probably even be happy if you got both. The only time that statement is false is if you end up with neither. And last but not least, we have the simplest, but sometimes the most useful logical operator, not. It's just a single exclamation point, and its job is super straightforward, but incredibly powerful. I love this reverse switch analogy because that's exactly what it is. Not simply takes whatever value you give it and flips it to its complete opposite. If something is true, putting a not in front of it makes it false. If it's false, not makes it true. It's that simple. Let's look at a quick example. We all know that the statement 5 is greater than 2 is, of course, true. But if we stick that not operator in front of the whole thing, we're basically telling the computer to give us the opposite. So not true becomes false. It's just a simple flip. So we've gone from simple math to comparing values to some pretty complex logic. But what's the big deal? What's the payoff here? Why do these little symbols actually matter so much? Let's put it all together. So here's the grand design. You've got your arithmetic operators doing all the number crunching, right? They're the engine. Then you have the relational operators, acting like the computer's senses, constantly comparing things and spitting out true or false answers. And finally, the logical operators are the brain, taking all those little true-false facts and weaving them together to create intelligent decisions. From your phone's lock screen to the most advanced AI, everything is built on this exact same three-level foundation. And that brings us to one last thought. Now that you're in on the secret, where else can you see this logic at play? Think about your social media feed. Why does it show you one post and not another? Or your smart thermostat at home? What other parts of your digital life, when you really get down to it, are just a massive chain of simple symbols and true-false questions all working together behind the curtain?